Mod 4, Systems of Linear Equations and Inequalities. We're going to start with 4.1, Solving Systems of Equations by Graphing. Our essential question is, how can you use a graph to illustrate the solution to a system of linear equations? By the end of this video, you will be able to find approximate solutions to a system of equations. Slope-intercept form. Reminder, slope-intercept form is that y equals mx plus b, where m is the slope, calculated rise over run, change in y over change in x, y2 minus y1 over x2 minus x1. All of these things are familiar. We've seen them before. The b is the y-intercept. It's where the line crosses the y-axis. The point 0, comma b. The b is the y point. The x value is always going to be 0 for the y-intercept. Standard form, ax plus by equals c. Remember, a, b, and c all represent integers. A and b are not both equal to 0. To find the x-intercept, that's going to be where we take our c integer and divide it by the integer in front of the x, the a. So c divided by a gets us our x-intercept. C divided by b gets us our y-intercept. So that's a quick review of standard form. Solution to a system of equations. A system of equations is usually two or more equations. The solution is the point where the lines cross. It's the x and y value where the two lines will meet. One, we need to make sure both equations are in slope-intercept form to easily graph. You can graph using standard form. That's your personal preference. Up to you. Graph both equations on the same graph. Solution is the xy point where they cross. Check algebraically by plugging in the x and y values and solving to see if the equation is true. Reminder to pause the video if you need more time to copy these notes down. Find the solution by graphing. Let's get into our first example here. We have y equals negative 2x minus 4. We pick out the slope is negative 2 over 1. Reminder, it's the number in front of the x, and we have to include that negative with it. Rise, we do 2 over 1 because we're talking about rise over run. Our rise number is 2, so if it's ever a whole number, it's just going to be over 1. The b is negative 4. We go to our graph to plot that. We need to plot the negative 4 on the y-axis. We plot the b first. Now we get to count the slope. We're going to go down 2 and over 1, right? The negative, we'll apply it to the 2 first, and the 1 is positive. So down 2 over 1. If we do the opposite, we go positive 2, well, now we need to apply the negative to the 1. So we go to the left 1. And we can create these points all throughout. You should always create as many points as you can throughout the graph before you draw your line. Let's graph y equals 0.5x plus 6. 0.5 is another way of writing 1/2. So our slope here is 1 over 2. Our y-intercept is 6. So when we go to our graph, we go on the y-axis, we go up to 6, plot our first point, and our slope is 1 over 2. So we're going to follow that up 1 over 2. And we've reached the end this way, so we need to do the opposite direction. We need to go down 1 and to the left 2. And we can create our points, and you maybe noticed an overlapping point here after plotting this. The solution is that point where they meet. The x value would be at negative 4, and we go up here to the y value is positive 4. Our solution would be negative 4, 4. We can check the solution algebraically if we plug in our negative 4 in for the x, and we can calculate that out. That would be 8 minus 4. Our answer for y is 4. That was our y point here. Checks out for this first, the top equation. Let's check the blue equation. We plug in our negative 4 into the equation, and we end up with negative 4 plus 6, which is 4. Therefore, it checks. So we can always check a solution algebraically. Let's take a look at this next example. Find the solution to the system by graphing. So if we graph this first one, the y-intercept, well, let's start with the slope. It's out of order here, right? The y-intercept is this number without the x. This number with the x is the slope. So the slope is -3/1. The y-intercept is 5. If we go to plot that, you probably already saw the points arrive here. The y-intercept's at 5. The slope is down 3/1. Down 3/1. And down 3/1. And we continue that throughout. Let's get this into slope-intercept form. So you can see if we use standard form, 25 divided by 15 isn't going to be a nice number. So if we don't want to deal with that, we can turn it into slope-intercept form by moving the x over and then dividing everything by 5. And we get y equals -3x plus 5. If you notice, the slope is the same, the y-intercept is the same. They are the exact same lines. Therefore, our solution is infinite. Because they are the exact same lines, any xy value that we pick will be able to show up on our graph. There is an infinite amount of points that would satisfy both equations because all of those xy coordinates would be on this line. Find the solution by graphing. We have y minus 2x equals 6. Again, you can get it in slope-intercept form. You could graph this one by doing standard form. I'll talk about that in a moment. But to get it in slope-intercept form, all we'd have to do is add the 2x to both sides. We get y equals 2x plus 6. And we can graph that with the slope of 2/1, the y-intercept of 6. And our slope is up 2/1. And we can go the opposite to get more points this way. And we can create our line. Remember, if you're doing standard form, if you were to do 6 divided by the coefficient of y, that would be 1. That would give you a y-intercept of 6. And 6 divided by a -2 would give you an x-intercept of -3. So that's where it's at. And you could draw those lines. The reason I like putting it in the slope-intercept form is it allows me to get more points on the graph to help us come up with our solution more easily. So same idea here. We could graph this with standard form. I'm going to choose to get it in slope-intercept form so I can create more points in order to graph. So y equals 2x plus 4. Slope is 2/1. Y-intercept is 4. So we go to 4, we go up 2/1, and you might notice that the slope is exactly the same. And when we have the same slope, that means the lines are parallel. Our solution, there would be no solution. The lines will never cross. So when we have lines that have the same slope and they're parallel, there is no solution.